I will begin by introducing Professor P.J. Narayanan, who has gladly agreed to be the moderator of this esteemed panel. Professor Narayanan, as most of you would know, is the director of IIIT Hyderabad, and he also wears the twin hat of being chair of the research board at ACM India. And like many of the previous track orchestrators and speakers, he's also a great friend of MSR India. So it's indeed a pleasure to have him orchestrating this panel. And I'll hand over to Professor P.J. Narayanan to introduce the panelists and take it forward.
So good afternoon, everybody. I hope you're all energetic after having a cup of tea. So we have a interesting panel. The topic is very broad, challenges and opportunities in AI. So AI has become a big, the biggest keyword in technology area these days. So much so that every company, companies have to claim to be doing AI or they are out. And the boardrooms are all asking startups and other companies, what's your AI strategy? What is this? So good thing is, people like me, I'm a computer vision researcher until maybe 5-6 years ago. If somebody called me an AI person, I would have denied. I would have said, no, I don't do AI, I do computer vision. Today, I don't mind at all. I'm proudly say I'm an AI person. So AI has come the whole circle. Interestingly, it's a paradigm that is bringing. So some people, old days in the computer vision and computer science thinking, there are only two or maybe three areas in computer science. One is theory, one is systems, and one is applications. Today, people are, and AI was thought of just an application of computers. Today, of course, everybody recognizes that AI is not just an application. There are many more things there. And especially of late, we know that the AI is, is data-driven. It feeds off the data that's available. And we heard excellent presentations this morning about data, and just the previous session about some of the very important but system aspects of AI. So, and data, of course, the famous people have been talking about data being the new electricity, or data being new oil. One of my friends who is a faculty member in IISc likes to say it slightly differently. Data is the new snake oil. So, which is actually also true, because data is being used to sell all kinds of snake oils to people. So it's also true that's actually one of the. Fortunately, we'll have, we just had a discussion, we'll have some of these aspects covered, how data can be used very effectively and sometimes abused or used for other purposes. You already heard some caveats about it in the morning. So that's where the area lies. AI has been, of late, also feared sometime all the jobs will go away, we'll all be replaced by some robot, software or hardware robots. From there, all kinds of predictions have been made about where AI and technology today will take the society to. Fortunately, AI also has a very useful and beneficial angle, and that's getting highlighted very heavily now, and everybody using it. Our smartphones or our computers are getting smarter in very positive ways. And that part is we all see. So with us we have 4 distinguished panelists. What we are going to do is to, I'll request each of the panelists to speak about 5 minutes from their perspective. They come with really diverse backgrounds, so you will see the problem, the challenges of AI, or opportunities of AI, data, and all these highlighted or from different angles. We'll start with, in this order, we'll start with Ravi Vadlamani. Dr. Ravi is at the IDRBT, a neighboring institute to us, almost. He's down the road, about 15 kilometers down the road from IIIT. Ravi has MSc Statistics from IIT Bombay and a PhD in soft computing, and he's been with IDRBT for a long time. And IDRBT, he'll talk about IDRBT a little bit also. IDRBT is a research division or institution associated with RBI. So he is going to primarily talk about the opportunities and challenges of AI and the financial technologies, banking and all that. So over to you, Ravi, first.
Thank you, Professor P. Jain, for the kind words of introduction. Before I talk about my views and experiences on the application of AI in financial services and banking, let me spend a couple of minutes on the institute that I come from, because it is not very well known to many people in the auditorium. This is Institute for Development and Research in Banking Technology, set up by Reserve Bank of India about 22 years ago. And it has got various activities, starting from teaching, research, training, consultancy. And then we recently started PG Diploma in Banking Technology. I had the Center of Excellence in Analytics over there, which was set up about 10 years ago. And as Professor P. Jain was mentioning, I have close to about 30 years of experience now in analytics, predictive analytics, you call it machine learning, soft computing, new AI, old AI. Well, I leave the choice to you. And in the process of one of the primary activities of this Center of Excellence in Analytics has been to conduct research in the cutting edge areas of predictive analytics and machine learning. And it is not a blue sky research, it is heavily application oriented. We were asked to work on the burning problems of banking industry and financial services industry. So in the process, we produced about 6 PhD students, and 2 are going to graduate very soon. And we have forged international collaborations with top-notch researchers from US, Belgium, New Zealand, Hong Kong, and several countries like that. And in the process, we trained about 900 executives of Indian banking system. Okay? And then we evangelized, we take pride in saying this, we evangelized about the concept of CRM, Customer Relationship Management and Analytics in a big way across the Indian banking industry. And as a result, you could see some of the banks, including PSU banks, are talking about AI and machine learning in their boardrooms. We have conducted POCs and showed them this is how you have to tackle the business problems using machine learning and soft computing techniques for 15 banks. Let me tell you, POCs for 15 banks, and they were thoroughly pleased. But if you ask me what is the ground truth now, I can hardly count on fingers, except for 3 new private sector banks, which you can easily imagine. In the PSU sector, the public sector industries, the banking, I think not many banks are doing except for SBI, where little bit of AI and data analytics is being done. But the rest of the PSU banks have to do a lot of catch-up work. And I'm leaving some pamphlet here. Those of you, if you are interested, some youngsters I could see here. These are all the activities of our Center of Excellence. You can just look at them. And talking about the kind of research that we did and the opportunities and challenges exist in the Indian banking space, let me tell you, we have got 6 major problems. Okay? The first and foremost is customer analytics, where we talk about picking up the data of customers, both structured and unstructured, and applying all sorts of machine learning techniques to solve problems like campaign management, customer credit scoring, and the default modeling. And then we have got other issues like fraud analytics, security analytics, cyber fraud analytics, and then we have got social media analytics. That is, in fact, playing a big role. The word of mouth is spreading like anything. Whenever you want to purchase anything, any small gadget to a big thing nowadays, you stopped asking your friends' opinions. You directly hit the net and ask for customer opinions and their reviews. The same thing is happening in the banking sector as well. So social media analytics and sentiment analysis plays a big role in banking. And then operational analytics. There are a lot of operational issues which could be tackled profitably and efficiently using machine learning techniques. So for example, the cash replenishment in ATMs. You may think that is a very straightforward job. Unfortunately, it's not so. So people have to figure out the kind of models, looking into the kind of withdrawal patterns day in and day out, and then replenish only that much amount, neither less nor more, for banking reasons as well as for customer reasons. And then a lot of risk analytics also is there in the banking industry. Whenever you are in the business of banking, there are lots of risks associated, starting with credit risk, market risk, and operational risk. Each one of these risks has got a lot of mathematics behind it. And with the kind of prevalence of data that we are seeing nowadays, a lot of data analytical techniques can be applied. And I can mention some of the case studies. So we are talking about some of the important challenges. So I would say the important challenge could be recruitment of highly qualified and trained manpower. That is where the biggest lacuna is there right now in the Indian banking industry. At the same time, I had the pleasure and pain of training, as I told you, about 900 executives. If you ask me what are they doing now, yes, many of them are actually want to jump into the bandwagon, but there are other HR issues and other kind of operational issues which are pulling them back, unfortunately. Having said this, banks, big banks like SBI, let me tell you, they have taken, in fact, they have beaten the track. They have taken the kind of a very, I would say, not offbeat route of recruiting about 100 people from the market. And by circumventing all the HR issues, they gave them market-related positions like assistant vice president, associate vice president, vice president, president. So these kind of titles are unheard of in Indian banking industry. And they are purely contractual jobs, so that the unions will not create any problem to them. So this is a kind of successful model worked out by, the HR model worked out by SBI. And I tell all the other banks, whenever I get an opportunity to speak to them, you copy this model shamelessly. Nothing happens. But then very few people do that. And private sector banks, I don't have to tell you, they are in the forefront of doing all these things. And there are good success stories over there, talking about whenever you want to place a new ATM in a specific geographical location, they are doing location analytics. And that is where people started doing now big data analytics as well as deep learning models. Banks like HDFC, Axis, and ICICI, they are in the forefront of using analytics as we speak. Even they are able to crunch large amounts of unstructured data about customers and various other things. So this is how I would say, for the youngsters and many researchers sitting over here, there is plenty of opportunity to work in the financial services industry within banking, within India. And if you talk about insurance, the less said, the better it is. Banking is a bit, I think, far ahead compared to insurance industry. But insurance industry is also replete with a lot of business problems which are very similar to banking, and there is a tremendous amount of scope to apply all the machine learning techniques over there. And financial services, if you look into that, the stock markets, the investment banking, and algorithmic trading, high frequency trading, that we keep hearing these kind of things abroad, US and US markets, European markets. But in India also, there are companies like WorldQuant, etc., which are hiring young guys with AI kind of aptitude and flair. So that is where, again, you have a lot of scope to do. And this can have a tremendous impact on the government sector as well. So I would say definitely there is a lot of scope for ML and AI and data science, the bigger umbrella I always talk about in Indian banking space.
Thank you, Ravi. But I'm glad he brought up the issue of manpower, trained manpower availability. That's a huge problem in India in these advanced areas of AI or data science or statistics and things like that. Fortunately, there are many math-trained people, and these premier institutions like IIT Madras or IITs and IIIT, or they do have programs in this, but that's not enough. With that aim, actually, we at IIIT last year started a large-scale certification program, AI/ML certification program for working professionals. And somehow we were not and still are not very convinced of the MOOC model. So our model is very conventional. Everybody comes to our campus, about 250 of them come, and we take classes, we give assignments. It's a weekend program. And so far we have trained in about 1,000 people so far. And what is most interesting is, these are all working professionals. Among the people who got trained, 35% or more have had 10 years or more experience in the industry. So it's not just the youngsters who are jumping at this as a career boosting opportunity. It's the people with 10 or more years experience. Maybe they are feeling if they don't have AI, they'll be left out. Maybe, there'll be fears there or maybe opportunities. So that's where things are. And hopefully they are able to do something in their respective organizations, but that's a big challenge. I will like to go to the second speaker. He's Professor Shankar Narasimhan. He's a faculty member right here in Chemical Engineering Department of IIT Madras. Professor Narasimhan had his PhD from Northwestern University. He has been working also associated with the Bosch, Robert Bosch Center. He will be talking about control and manufacturing and so on. A very interesting perspective, Professor Narasimhan.
Thank you very much, Professor Narayan. I am from the Chemical Engineering Department of IIT Madras. In case you're wondering what I'm doing in this audience, let me give you some reassuring words. I am from the Systems and Control Group, which consists of about 6-7 people. And we have a strong presence, in fact, strongly, very closely related to Robert Bosch Center for Data Analytics. Primarily, if you look at what the systems and control people do, besides looking at the design of large-scale systems, we also look at operational management, which involves 3 main activities, I would say. Modeling. We try to understand behavior of the system from data. Then we try to actually control it. We try to actually change the behavior to suit our needs. And lastly, we do optimization. We try to maximize the profitability from this process operation. So in many of these cases, we do make use of models which are either derived from first principles knowledge, but a significant amount of effort is actually spent in deriving models from data. In control, in fact, largely we have been using models derived from data. And if you look at the methods that have been used by the systems engineers, especially working in chemical engineering, neural networks was used in the early 80s when I started my PhD. It was a big, what I call buzz at that time. And we used expert systems at that time. We tried to actually leverage whatever was happening at that time to improve our modeling as well as control capabilities. But afterwards, it died. It didn't take off. I think recently there's an article by a chemical engineer, who's again a systems engineer with whom we collaborate, who has written a thing of why this is coming, why this is going to make a big difference now. 3 things: computing power, significant increase, cost has come down, ability to sense a lot of data, sensor cost has come down, so you're able to get a lot more data, and also you are able to transmit communication capabilities. You are able to transmit this data over, geographically large distances without even wiring. Right? I mean, these are 3 things that are just going to make a difference, other than the development of tools and techniques to deal with this large-scale data itself. So the focus of most of the people in the chemical engineering community of, say, systems is data analytics. We look at data analytics. We use a lot of these tools that have been developed in the machine learning thing. We call them data analytics tools and use them. And I have a company that actually uses some of these techniques to apply to manufacturing and process industries, primarily with the aim of improving operational efficiency. That's where we are. So let me give some examples where I think there are parallels. So if you look at fraud detection that people are worried about in the financial sector, fault diagnosis is a big area in chemical engineering. I mean, I think, a lot of interesting ideas, methodologies have been developed by chemical engineers, and I think many of these can be leveraged. It is about detecting when a problem will occur in a plant from data, and trying to actually figure out which part of the plant or which sensor has gone wrong or which equipment is not performing very well. So that's the kind of things that we use. We have been primarily using quantitative data, right? But the representation ideas, models, and so on could probably be extended to even textual data and so on. We have not integrated textual information in our thing. That's what we think we can leverage from the current what I call methodologies that are being developed. How to incorporate information which are not quantitative in nature, and how do we actually enhance our techniques. But we could also cross-pollinate. The methodologies that we have developed could actually be useful in other domains. Trend analysis. We do a lot of trend analysis, especially quantitative trend analysis. And we have used these ideas in analyzing stock market trends, in fact, applied to several companies, because that's more profitable for us than trying to convince the manufacturing industry to part with their money. So I can see there's a fair amount of the methodologies that we have used that could actually help in the emerging thing. Where we actually believe we are behind, we don't use too much of image and video information in our inferencing mechanisms. No, we don't try to capture a figure, a process flow sheet, for example, which we develop in our thing. We encode it in different ways, but actively we don't take data about eye movement, for example, of an operator and try to figure out whether he's understood how to operate the plant. So these kind of things are now being explored, but I think that's where I think the AI community, whatever it's being done there, we could borrow to enhance the manufacturing processes itself, improve manufacturing process. We are definitely don't use significant amount of audio and audio data and speech data. For example, although there is some effort in trying to monitor the performance of machinery using audio signals, or monitor the corrosion in a pipeline using acoustic signals and so on, But significant amount of this in online thing has not been done as yet, which could actually make, again, a difference. So primarily, we have been dealing with data which we are sensors, which are like temperature, pressure, concentration levels, and so on. But these kind of sensors, audio, video, images, and so on, have not been integrated into our techniques, where I believe that's going to, and textual information, documents that you actually have. That's where I think we should be able to improve the methodologies, at least thing. What are the challenges I see based on experiences that we have had in the last 8 years trying to apply these techniques to manufacturing? The first thing that I would say is the islanding of data. Despite all the automation that's been done, even if you look at an oil refinery, which is extremely well automated, hardly anybody takes, there are no manual decisions made. Right from planning to where to actually order the oil from, how to actually how to schedule the refinery in terms of what crudes to process, what products we should produce, how should we market them, supply chain. Significant amount of automation and methodologies, automated methodologies have been done. Despite it, if you look at the data storage, it will be lying in different islets. For example, the business data would be in a SAP system. The operational data would be in a SCADA system. The lab data, where we actually make concentration measurements and test the samples, would be in a lab information system. And integration of this has to be first done if you want to leverage. They are all kind of, they don't talk to each other. There's a significant effort we have to make in order to kind of get the data into one place so that we can analyze them together. Even if some of the things are not big data in the way you talk about in computer science, but nevertheless, the diversity of the data, we are not. In documents, for example, the design documents are not available anywhere. They might be available in some kind of static system which are not accessible online. So all of this integration is going to take time. Some effort has to be made to bring in this data into a common platform so that we are able to leverage this and make better inferences. The second thing I find is also in many of the things which are not so well automated, where manual intervention there, the quality of the data is very abysmally poor. Especially in this country, we don't seem to have paid an attention to the maintaining an honest database. We don't want to tell the truth. We want to, the general, the attitude of operators and so on is not to actually record what they see. They record what they think the manager like to see. So I think it's completely, the data is totally useless. If you want to make really strong inferences, there must be honesty in the way we record our data. Automated systems, you don't have this problem, but there are several, I would say, medium scale industries and so on, where the data capture and storage is not time synchronized. For example, a classic example is regex in a foundry, right? They produce like pieces every batch of, let's say, 10 minutes, and a part is rejected. But these rejects are all thrown into one pile. At the end of the week, they essentially say how many parts are rejected. But you don't know what was the processing conditions under which this part was made. Unless you time synchronize the data, you cannot make valuable inferences between processing conditions and rejects, and thereby give them good, let's say, decision-making capability. So I think time synchronization is a very important thing that we are missing out. There is, of course, honesty in terms of recording the data, and also in the silos that we have. All of these have to be solved in order to actually leverage the techniques. The second thing is it's not clear what are the kind of advantages we are going to get besides improvements, right? Obviously, operational improvements is going to happen, but is there going to be a giant leap in the way we think about these things? I will give an example. So we work extensively in water distribution networks. And one of the problems, we have excellent techniques, algorithms and so on, we have come up with and how to operate them efficiently. But the first problem that most people in India at least face, if you talk to a infrastructure company, they say, look, I don't even know what the current water distribution network looks like. There's no drawing. Can you reconstruct it? Can you somehow construct this network, which is lying underground mostly? Can you come up with this network diagram? And I said, I don't know how to do it. You have to dig up the whole earth and probably find out where the pipes are, or you have to go with a ground penetrating radar and figure out where the pipes are laid. But he says, well, there's another way of doing it. You talk to people who have operated this pipeline. Okay, they will tell you some information about where the lines are running. That's a qualitative information. Typically, design principle says that the lines are laid along roads. So you know the road structure map. So you can use that as a first level understanding. Third, you know where the reservoirs are coming out of the ground, right? You know where the overhead reservoirs are, where the valves are. So you have some idea where the pipes are running. You don't have the network structure, but you know at least it is passing through these areas. Can you combine these kind of unstructured, diverse information in order to come up with a plausible network? Look at this is where how the human mind will work, right? We are not solving such problems as yet. We still are making those incremental changes, and I don't believe that we are thinking out of the box in order to leverage or solving problems like the announcements that are made. You know, there's a computer that can actually learn how to play chess or Go by just giving them a few rules and do iterative learning, right? I mean, I don't think we are thinking out of the box in terms of solving engineering problems in that way. So I think there's a lot more out of the box thinking required in order to exploit the tools and techniques. I'd stop here, but later on if I think
Thank you, Professor Narasimhan. I'm glad he has brought out the second big challenge that any AI system faces is data. There may be both availability of data, and if it's available, their reliability, and even if their reliable data available, their coordination all together. The third speaker in the panel is Ganesh Shankarlingam, who works with a company called Latent View. It's a 600% company, not a very small startup in this space. Ganesh has an MS from Texas A&M University, and he's been running this company for a few years. Ganesh.
Thank you for the warm introduction, and thank you for listening to me for the next 10 minutes. Latent View Analytics, we also, so I lived in the US for about 12 years. I've worked in Japan, and I've worked in India as well. My area was in the first 10 years in optimization, and apparently now it's being called AI as well. It's been rolled up under AI. I'm very glad about that. And in the past 8 years, I've been working with Microsoft. Microsoft is one of our key accounts. I'm going to talk about one of the key problems that we solve there, right? We work with the CMO team, as I was telling Saikat, that a lot of these companies have millions of dollars, hundreds of millions of dollars in terms of the budget. Where do they send it? Do they put it as, organize conferences like this? Or do they go ahead and spend it in, Google search engines? Or do they do it in social media? Do they place ads in TV? How do you go about solving it? Very easy, right? There are machine learning models. Compute power has become easy. We built close to 500,000 to 1 million machine learning models to find out what is the right mix they should solve. So that part has been solved. We solved it, and we presented in papers, large conferences and all. It's been recognized. The problem is, within a business, AI needs to be interpretable, right? All the machine learning algorithms, if I take it in front of a CMO, he's going to ask, how did it come to this number? Just don't give me an Excel file with 6 numbers. How did it come to this number? So my suggestions to the AI research community, previously we used to measure our models in terms of runtime and accuracy. Now that's gone because there is enough compute power out there, right? And accuracy is improving quite a bit. The third piece is what we keep hearing from our clients, interpretability. The same thing, if I can look at it from a driverless car, why did it make a right turn instead of a left turn? Without interpretability, nobody is going to trust your model. Nobody is going to get into that car, right? I don't know where it'll head next, right? So if there is an area for business community to start using AI more, the focus would be on interpretability of the models. We do have the data silos problems. Infosys and TCS have built billions of dollars of business, trying to solve those data silo problems, but it'll continue to bear that. Those are the foundation problems. You need good data, junk in, junk out. That's what we used to call it, right? If good data goes in, you'll get good decisions coming out of that data by running models on top of it. Those problems will continue to be there. So that is in a second area, right? How do you build good data engineering platforms with the latest cloud technologies, right? Interpretability is one. How do you do the data engineering good platforms? And the third thing which businesses face would be more on hiring the right talent, right? What do you need? There's so much of requirements, right? I'm a mechanical engineering, by the way. What is a mechanical engineering and optimization working for Microsoft, helping them with their marketing problems, right? How do you end up training the right kind of talent in education institutes? What are the key requirements, right? The way we look at it is, I was involved in setting up the IIM Calcutta's PGDBA program, right, with Dr. Bose. They break it into 3 different variables. One is they send the PGDBA MBA, in addition to the regular MBA that they have in IIM Calcutta, 6 months of programming, right? They have to learn programming, C, Java, Python, SQL, some of the programming skills. 6 months of stats, right? They go to ISI, Indian Statistical Institute, and go ahead and learn stats and maths and both the Bayesian side as well as the machine learning side, both the spectrums, right? And third would be the business problem. How do you take a problem? How do you formulate a problem? How do you break it down and how do you solve it, right? And then finally, a project. These 4 are critical. What I see a lot of institutes doing is focusing on 1 or 2, but they don't focus on all 4. And this is what is required to solve future challenges this country will face with data. You can't have 4 different people. It needs to be one person who knows all 4 things, right? So this is the problem businesses are having. These are the constraints. How do you train people to overcome these constraints, as well as interpretability from a pure algorithmic perspective? We've seen very few products available in the industry, at least for us to use. So that is on the business side. Let me talk about the consumer side. So we work with BMW. We've got like 10 million cars data, right? When I say cars data, cars have computers that are as powerful as the machines we used in 2000, 95, 2000, right? Windows 95, Windows 98 machines, they're as powerful as that now. Each car has computing power that powerful. So it records how fast you drive, how hard you accelerated, how hard you braked, right? How fast did you steer and everything, right? They started using that data, and they've already built, it's not a theoretical thing which is going to happen in the future, they've already built a risk score. Just like you have a CRISIL credit score, they have a risk score for your car. Again, BMW has it, Maruti doesn't, because BMW has a lot more sensors. They can afford to put a lot more sensors. Maruti is still a little lower cost, so they haven't put those sensors in. So the key problem where they are facing is insurance, right? Coming to your finance, banking industry, I can clearly say which part will fail next. How accident prone is this car? Completely based on the data, right? When I was in the US, if I was less than 25, my insurance rates was double, right? After I crossed 25, my insurance rate dropped, even though I was a safe driver. No more, right? They'll start using the cars that you have driven, and they'll find the data from that, and then they'll say, this car, resale value. When you're putting it in the market, you'll get a better rate, right? Insurance values will come down. Which part will fail? Predictive maintenance will start kicking. They will call you and say, by the way, next week this part is going to fail. Please bring it in, right? Those are the things. But what is stopping them? So I told you about the constraints we have in business side. Interpretability is the key constraint and resources. In the consumer side, what's stopping it is a very important factor, data privacy, right? Would I like to be monitored, right? And it can be used against me. If somebody doesn't like me, the police can come and arrest me. Yesterday you're driving in a 50 kilometer zone, you're driving at 80 kilometers. You made 3 mistakes like that. I'm going to put you in jail. Very easy, because the data is not private. So what are the rules that governs that privacy? So before you go ahead, you can bring down farmer suicides by significantly if you start looking at their Aadhaar transactions, all the other data, and put a credit model and directly sell it to the public banks, right? And you can build a very beautiful model, but then that same data can be misused by others in the wrong hands, right? So in the consumer space, I've given you an example of automotive as well as banking. There are a lot of opportunities available, but what's stopping the adoption needs clarity in terms of data privacy. So with that, I'll probably stop here, and I'd love to take questions at a later point. Thank you.
So the third aspect of today's big exuberance about AI was brought out by him. That's one is interpretability, how to use it in at least critical, like say medical domain. We don't know what the system is doing. The beautiful network is giving this decision, just do it. I mean, that's very uncomfortable. And second aspect is also talked about the misuse of data. That brings us nicely to the fourth speaker. Is Dr. Saikat Guha. He's a researcher at MSR. Saikat has a PhD from Cornell. He works in security, privacy, and those issues. Most importantly, he's been involved for the last few years with what they call Data Map, the platform, Microsoft's framework to define and comply to the GDPR privacy rules that came out in Europe and probably will come out in other countries. So, Saikat, your time.
Thanks for the introduction. So, like Professor Pijain said, I've been working on security and privacy a couple of years ago. I was working on the fraud analysis on the Bing advertising stack, and that's one place where we sort of started with maybe hand-coded rules, and over time we evolve to machine learned models, and we can see sort of the difference that new ways of leveraging data actually brings to business needs. And then more recently, as was said, I've been working with the privacy and compliance teams within Microsoft to help our compliance efforts to the European Union's General Data Protection Regulation. And in both these sort of cases, I'd echo back again some of the challenges that were brought up in the context of AI, which is how do you ensure that data is being used for the correct purposes and not for incorrect purposes? Data might have been collected for one reason, and the user consented to that particular use of the data, and you want to make sure that once the data is within the organization, it gets shared broadly around, that no one else in the organization uses it for a purpose that is contrary to the purpose for which the data was collected. And that's a huge, huge risk when it comes to sharing data. That's what creates these sort of data islands that was being spoken about, which is that we do not have systems and technologies to ensure our compliance with these needs. On the other hand, when it comes to just using AI models, again, because people don't even understand what these models are doing, they're even more averse to using this data, which could enable massively important societal applications, like was being said about helping farmers. But simply because people don't know what these models are going to key off of in the data, people are super hesitant because it may or may not key off of a protected attribute or a sensitive attribute. If you look at examples in the US, where judges are using AI models to decide whether someone should get a bail or not, now the sad fact is that the data that they're learning on is based on histories, and history has been based on years and years of discrimination, implicit discrimination by various judges, where people of color often do not get enabled bail application. Now, if you learn from that data, create a data model, well, that's just going to amplify the latent biases that are in society. And so how do we make models that, to an earlier point, that are interpretable so that we can actually see why a decision was made? If it was made due to an unfair reason, that we can strike it out. How do we make sure that regulation actually enables something like this happening? So if you look at the General Data Protection Regulation in Europe, they have a very first initial stab at doing something. It's better than nothing, but essentially what they said is that EU citizens have the right to ask for a human review if they were ever subjected to a totally automated decision that has legal impacts. An example being your insurance being denied, or you being denied a job, or you being denied a housing loan, or being denied a particular house. You can actually request a human to review it. Now, is that the best option? No, because you cannot scale a lot of these decisions if every single decision has to be reviewed by humans. But at the same time, what is their option from the perspective of the regulators that need to protect society? What other alternative do they have to make sure that data is being used correctly, other than say, well, let's fall back to a human to review your case, so that if it becomes clear that a sensitive attribute was used, at least we have someone who we can hold accountable. Now, there's no way to hold an algorithm accountable, and that's the problem that regulators have. So in addition to some of the cross-discipline stuff that we talked about, one thing to consider is how do we bring in the regulators, the legal minds of the world, to help figure out what's the regulatory framework within which both industry can thrive in being able to use data and being able to use AI, but at the same time, society is protected.
Good. So maybe we can have, any of you want to comment on something, something that came to your mind based on what somebody else said. A little discussion among the panel before we open it up to the crowd people. So of late, you're asking Saikat, of late, rather than misuse of available data, there's also fake news and fake data, which is controlling as much as elections. I mean, the most important thing in the world. It's been too much in the news. So, what are the solutions available to prevent such things, or at least reduce such things, if any?
Yeah, that's a fantastic observation. That, I mean, data can be used for both good or bad, right? It comes down to, essentially, AI is amplifying humans. there's the usual saying, right? Guns don't kill people, people kill people.
Yes.
It comes down to saying that, AI models are not giving you fake news. The question is, who are training those AI models and what goals are they training it for? Now, if you look at certain social media companies, right, if their goal is to enable engagement, and it just so happens that face news is going to enhance the engagement, and that's what those teams and businesses are being compensated on, then yes, unfortunately, that is what we will get, because the business imperative is to make sure users stay on the site, keep interacting at whatever cost, so long as the business makes money. And so to your question about how do we actually change what is happening with fake news, is to figure out, can we enable alternative business models for these companies so that they can actually make money without benefiting from just polarizing society and just keeping them hooked onto this content.
And talking about the data, I forgot to mention that the data quality across Indian banking industry is atrocious, to say the least. We dealt with the data firsthand. We are in the best position to judge the data that is available. But then we say that don't wait for the day when data becomes 100% good data quality. You have to start this revolution somewhere. Otherwise, you will be left out of the race. And already there is onslaught of a lot of foreign banks coming into India, and your customers will be going in a kind of queue. Exodus will be there. And the third thing that I'm reminded is the NPAs. Many of the banks are bleeding right now. We keep hearing in the newspapers, the non-performing assets, or the, so to say, default. You must be hearing some big names leaving the country and all that. So that's where actually a lot of research can be done. Right now, to the best of our knowledge, a lot of data-driven models are not being deployed. So that is where AI has got a lot of role to play. It can actually leverage both the structured as well as unstructured data about the customers, be it retail customers like you and me or the corporate customers like big wigs, and then develop the proper default models so that they can know very well well beforehand that these are the kind of high-risk customers whom if we kind of lend, there is a high probability of not getting it back. So there is a lot of work to be done in this particular space, and probably I just stop here.
Okay.
And then,
You have some comment? Yeah.
I just want to pick up on one of the items that Mr. Ganesh spoke about, which is interpretable AI. Surprisingly, 30 years ago when expert systems were used in the 80s, early 80s and so on, the same question was asked, really. I mean, how is it arriving at this decision? Then they had these chaining rules and the thread of explaining. They actually not only provided the decision, but also showed the set of rules that were used and actually gave that as an explanatory thing. One of the possible ways is actually we are asking how much of domain knowledge, at least in the engineering and the area, science and engineering area, when you apply, domain knowledge has been extended. We have been, these are governed by physical laws which are fairly well understood. And today you have a lot of data. So is there a way of combining both of this in order to provide these explanations rather than simply relying on data? So at least in the science and engineering area, I think there's a possibility of coming up with not just purely data driven, but also provide an explanatory note by actually synchronizing it with domain knowledge.
And so the talk of interpretable AI triggered something for me, which was, if you ask the question, yes, interpretable AI is important. The question is, why is it important? And some people already spoke about it. Like if you go to a CMO and you say, hey, I have a deep learning model, and they want to understand why. It's not because, it's not a curiosity thing. It's not like they want to know why is it doing it. But it's more of a business imperative that, hey, prove to me that this model won't go off the left field tomorrow suddenly when some weird little data point shows up. That the self-driving car example, that will prove to me this thing is not going to jump off of a bridge when something weird happens. The interpretability is not for curiosity. The interpretability is for guarantees that this particular model is not going to do something completely bad. Now, that's one potential way of getting to that answer. That is, hey, it's interpretable, so I can see what it can or cannot do. Other ways are to put theoretical proofs and guarantees around a particular ML model, and that's something that is sorely lacking today, where, yes, we know these ML models work, but we have very little rigor, very little theoretic frameworks to give guarantees about, hey, this thing is never going to be more than 2x off or what have you. That would, again, address the core issue, which is that, assure me that this ML model won't do something weird.
Okay, so this is These are times of frenzy where the practice is running very ahead. Hopefully the theory will follow a few years. So we have about 5 to 10 minutes left. 5 minutes left. We would like questions from the audience. Please, if you have a preference for one of the panelists to address, please mention that.
Audible, sir. Good evening, sir. My question is from sir from NetInview, sir. Sir, when you said that there is a less number of people who are working here, is it because the companies don't want to bet on young talent? They want people who have experience, like 5 to 10 years of experience, not maybe in AI, in the industry as a whole. Maybe they don't want to invest, or they want to bet on people who have less amount of, like 1 year or 2 year experience in the industry. Maybe in AI, maybe in other experience, but they have less amount of experience, and rather than the people who have more amount of experience.
I think I'll try to understand. Yeah? So it's nothing to do with young or old. It has to do with 3 skills: ability to program, right? And the ability to understand math. If I can give a simple regression problem, simple classification problem, ability to program, write a SQL line, do an inner join, take data from a Teradata database, put it in Excel, talk to a client. These are the 3 things you need to do to improve your sales. These are the 3 skills being looked for. As I was saying in the PGDBA program, this is what they do. They take 6 months to teach people programming, 6 months to teach them math, 6 months to do the business side of problem, and then 6 months of projects. If people have this skill, industry would be happy to take them, right? Even if they have 15 years of just business skill and don't have programming skills, they will struggle in the job, right? So, and then the first thing would be exploratory data analysis. Then the next thing would be insights. The third thing would be the ML models, right? That's how it goes up. So if students can start, I understand, sir, you had reservation on the MOOC models. A lot of them have reservations on MOOC models. But MOOC models are available, right? You can choose, like NPTEL has a very good program. A lot of faculty from IIT are doing it. It's a combination of MOOC and offline testing. Start early. Start it in your first year. Start doing that, right? Do 2 projects. You would be in a very good position to get a job in the industry. First, and you should have the discipline to work with one company for 3 years, go through the cycles of 2 or 3 projects, and then go into the AI ML space or go for higher studies. Then you would be able to build a very successful career in AI.
May I add something?
Yeah.
Actually, I would feel that it's not the fault with the other side, your side. It is on the supply side, demand side. See, basically, I know of one bank, which I cannot name for obvious reasons. It has hired about close to 40 very bright MBAs from top-notch IIMs. And within 2 years, except 2 of them, remaining 30 or 38, they left. So it's not because of their fault, but because I would say they were not given the proper work so that it gives them job satisfaction. Okay? So they wanted challenging job right from day one. Somehow that was not feasible in that bank, and they left. All of them left en masse. So the problem could be either this side or that side. So you don't have to every time blame the student or the candidate side. Okay? Maybe they were not mature enough, I would say. The mindset is not proper so as to retain these guys and give them proper work. So it could be that way also, why you people are not preferred.
Okay, question here.
Thank you so much for this wonderful panel discussion. Thank you so much for actually awakening us to this thing as well, that BMW is going to have that kind of capability where your insurance rates are also going to be decided on that how you actually drive the vehicle, right? While we keep on thinking about the applications of AI to a large extent, but at least this minute extent, I could at least never think of. So I firmly believe that the life is going to be much more challenging from here onwards. Anyhow, the panelists talked of different challenges about this. Data collection is a challenge, right? Although we do have sensors which are making the task of collecting the data very easy. We were listening to the talks in the earlier sessions that the sensors are becoming very easily available. And then privacy of data concern was raised. Interpretation of data concern was raised. Similarly, the manpower to do all this, that concern was also raised by one of the panelists. And the question was echoed by one of the young persons also. My only thing was, what I was wondering was, see, whatsoever data we are collecting through all these mediums, whether it's a BMW car or through whatsoever sensors or agricultural data, this data remains very, very unstructured data. very, very, very unstructured data. None of the panelists has unfortunately talked about that. There is a stringent need to first clean this data, to bring it in the form where some decisive and some kind of right decisions can also be made. So I would just like to hear the viewpoint of the panelists on this.
I'll take a shot at this. Okay. Talking about banking sector, we also, on a highly frequent basis, we produce what is known as frameworks and best practices for banking industry. So to address your problem, whatever you said, data quality assurance within Indian banking industry, 2013, I guess, we released a framework to be adopted in Indian banking industry, using which, for the new data as well as old data, there are methods suggested, best practice taken from world over, and it is not just prepared by academicians like us. We got consultation with industry, like the SaaS, IBMs, and Microsofts, and then we had consultation with the industry IT guys also, and then together bankers as well. So three of us parties sat together, and we came up with best practices, and this is free downloadable from our website. So there are, but if you ask me which bank is following that, that's a big question mark.
No.
I cannot answer that.
I'm not going to ask you that. See, that is okay. That is more of the related to general guidelines. I was just interested in knowing about the technology available for cleaning such humongous amount of data.
We mentioned all that, sir. We mentioned all these things.
Dr.
So
Saikiran
you had some observation about data in the manufacturing, yeah.
Of course, it's one of the biggest problems. Before you apply any of the techniques, you have to ensure that the data quality is good. So we have some automated methods for today. For example,
It's okay.
For example,
Working.
yeah. So for example, if somebody provides the data for any attribute, so you look at the data and say how many values of this are basically the same, right? It's if 2.13 is repeated several times, okay, we know this is actually artificially cooked up data, because we know inherently the variable has to exhibit variability, and unfortunately the data that's provided does not provide that show that variability. So we immediately flag it and say, please counter check it with the thing. The other kind of thing that we do is simple conservation principles. So you produced a certain number of items in a day, and then you mark the number of items that are rejected is more than the number produced, right? Counter check. The mass balance has to be obeyed, as we call it. So we have basic counter checks that we can actually, rules that we put in as a first step to flag all the data points which are, let's say, suspect, okay? And we ask the user to curate it, or we don't use it in model building. So I know it doesn't solve all the problems, but it certainly there are some automated ways of curating the data. Of course, the other thing is, so whenever we do diagnosis, we want to have exemplars which indicate this operational, what I call conditions will lead to bad data. You need to, or products which are going to be rejected. Who's going to annotate that, right? If you time synchronize it, we can actually figure it out, but you can't. Sometimes, what happens is the collection process does not actually even permit this kind of thing. So those are areas, of course, we still are facing challenges, at least in the manufacturing domain.
So data cleanup is one thing, but for to be actionable, you also need annotation. That's a huge, that requires expertise, that requires time, effort. That's a huge problem.
See, example, for example, the supplier of sand, right, in a foundry, you change the supplier, and he supplies you something that's quite different. That's never annotated, at what time the change occurred, right? These are things that are done routinely in a manufacturing thing, but nobody will tell you such a thing has happened, such an event has happened. You change the supplier or you change the source where you're getting it, and that makes it difficult to make meaningful decisions there.
I'd just like to add one more thing, right? When the BMW case itself, the data was sensor data coming out at every second level. So when you say modeling, I'm talking about two modeling. One is the data modeling. How do you capture that sensor level data into a model? And that data comes from sensors, so it is by definition unstructured, right? So there is this data modeling aspect. There are a lot of methods available, right? And that is a part of computer science. And then there is the math model aspect, where you put the math algorithm, like a regression model, a classification model, a neural net model, deep learning model. So both are inherently a part of AI. And how do you do that? I usually give an example, right? I tell my son, you'll have to learn English, you'll have to learn Hindi, you'll have to learn Tamil, that's your mother tongue. You'll also have to learn Python, you'll also have to learn SQL. To interact with humans, you need all these three languages. And with interact with machines moving forward, you'll have to talk to machines. You'll have to learn these three languages, and Only then you'll be able to understand the unstructured data they're giving back to you. Anyway.
So I'm going to make an observation. I don't actually work and put wooden coats AI, but I feel like this is all just a regular evolution of computer science. I mean, many of the things you talked about, we had been doing well before any of this, AI thing hit us. For example, the card analytics, there's a company called Cambridge Telematics, came out of Hari Balakrishnan, who was actually an alumni of IIT Madras. And he was doing it 12 years ago, which is like looking at data that was coming out of cars. For the banking thing, you said where to put ADM for data center networks or for data centers. We used to actually do that to figure out where to put a data center we used to take all kinds of things into account. I think for any other field to really become big, you need, I think Saket's hit it on the mark when he made the comment, which is that where is the verification? Where is the monitoring? Like, for example, we build networks, then we build monitoring agents to see what's wrong with the networks, and we figure it out, and then we found where the problem is. So my assertion is that you're not going to see any of this AI stuff for any mission-critical things. And things like, for example, looking at people's credit card scores. I mean, we used to have, in fact, we have 3 credit card agencies in the US which put scores for everybody, depending on how you spend, and then based on that, they give you credit. So all this stuff had always been happening. So to me, it seems that there's a lot of hoopla around things and around things that we were already naturally doing. And so I don't think anybody in the audience should sort of feel like if they were doing computer science, they were probably on the right course. So I'd like to hear your element that is it actually fundamentally different as to what is happening now versus what we are evolving towards? I mean, you talked about video, right? I started doing video analytics, and without knowing that I was doing AI, and then I was put on panels saying, "Hey, you're doing AI." I mean, so.
So there is hoopla. I think everybody here agrees, right? Everybody is talking about AI. There is definitely hoopla, no doubt about it. But the fact is, what I was doing 18 years, 20 years ago, when a grad student sitting in a corner doing computing, I was using an Excel, internal structured data to make decisions. Right? Whatever my company was doing, I'll put my sales data, I'll sit down and do it. Now I use external structured, external unstructured, internal unstructured. I'm using a combination of data. The volumes have tremendously increased. I'll give you an example on the credit card model that you spoke about, right? Banks, what is the average time it took for a bank to clear or get you a loan of, let's say, I'm a retailer, I'm a small guy selling something here. I need, Diwali season is coming. I need 5 lakhs extra cash to go ahead and stock up more and sell.
Can I counter on that?
Yeah,
Alibaba with Alipay completely changed that, and it wasn't about analytics. It was about mobile payments. They got it done. They got the data in there, and then based on the credit history, they give you loans at the spot right away.
Yeah.
So this has got nothing to do with AI.
No, I disagree with you. So we did the same thing for PayPal. They built a risk model, and risk model is all about analytics. For every seller that they had, they went ahead and looked at that model. It took a small retailer to get at least a week to clear the loan in an offline world. They moved online, it probably took a day. They were able to clear a loan in 5 minutes, $100,000. No human intervention, completely by the machines. It'll go and look up his history for the past 15 years, say this guy has been selling properly, very few returns, he's been making payments promptly, and within 5 minutes. What would have taken me a week to get a loan to go ahead and increase my business is taking me just a few minutes, right? So that, to me, there is definitely hoopla. I do agree with you, but I'm just giving you in finance domain, right? And one other thing I always say, right? You're right on another aspect, right? Humans were created, humans started talking to each other, and humans started becoming intelligent. Machines were created, let's say steam engine. Machines started talking to each other thanks to internet. Now they are beginning to think. The whole AI community is about making machines think more and more. I can tell you so many projects we have worked on where there were 150 people just looking at image and classifying or just looking at news. Projects have been reduced to 5 to 10 people. I can tell you so many projects in the chemical industry, mechanical industry, where the scheduling was happening, right? Where there was 150 planners. I've worked with them myself, right? After the automation, after we put in optimization, classification, regression models to forecast, it was brought down to 10 to 15. Machines are definitely replacing humans, and you would see that more moving forward.
So many of the problems are were worked on for ages, like credit score, but far many more signals are available today. Yes. And that's where the problem, the opportunities and the problems are, right? And I mean, you mentioned Alipay and other, the so-called social score that they supposedly use in China. I mean, these are things that are, so based on the use of social media data to score you in whatever way you want. That definitely was not possible because there was no social media of this scale on those days. So yes, the techniques or the problems are probably very similar to what they are, the intent, but lot many more data and lot many more tools are available, and hence lot many more caution is required. This is my take on this.
Yeah, see, my point was that this is just natural evolution of how things are moving. So, for example, you guys mentioned things like sensor networking was around for a long time. I mean, the NSF spent $50 million on a UCLA center for that nothing, and they were like monitoring buildings, and they were talking about capsules that you sort of have, and your body gets monitored. So, and this was all before any of this stuff hit. So what I'm trying to say here is that for everybody, the way I internalize this is to not sort of feel like, oh, this is a brand new thing that has happened. To me, this is just a set of problems that we have been working on. But now, yes, I agree. You've got more data coming in, and you've got more elements to it. Yeah. So you apply that and you solve the problem. I mean,
they're happening at internet scale and at speed of light. I mean, these are the two things. So the problem has gotten far more complicated as a result. The intent was probably very similar to what they were earlier. But it got very complicated because the scale, as well as the noise as a result, and the speed at which things are expected. Maybe we should just, we'll wrap up.
With that, because we also have a poster session before we kind of wind up, so I'd like to call it in. I'd like to thank this wonderful panel for all the insightful comments that they made and the lively discussions that they sparked. We'd like to, of course, give them a round of applause and also hand over a small token of appreciation for their splendid contribution to this event.